Scientists have known for many centuries about the mystery of cannibalism in the cosmos. Even our very own Milky Way Galaxy is involved in this weird act. But recently, humanity has discovered something big and powerful in the depths of the universe, with an enormous gravitational force that's twisting and pulling all galaxies within the cosmos toward an unknown region in space. But what exactly is this mysterious force? Why is it pulling us with such great intensity? And how will it affect the Milky Way Galaxy? The remarkable advancements of space technologies over the recent decades has led us to a new era of outstanding discoveries within and outside the Milky Way Galaxy. The more recent and perhaps the most terrifying discovery made to date is this mysterious galaxy eater located just outside the Milky Way along the constellation Centaurus. This region, often called the Zone of Avoidance, is known to contain dust, gas, and stars that obscures our view of the area from Earth. Within the Zone of Avoidance lies the Great Attractor, which is best described as a gravitational anomaly. Thanks to technologies and concepts like X-ray and radio astronomy, cosmic researchers have been able to explore the Zone of Avoidance, and guess what? They found the neighboring Andromeda Galaxy is racing towards the Milky Way Galaxy at a reported speed of about 70 miles per second. Both are expected to merge and become one galaxy some 5 billion years away from now. But that's just a tiny bit of the whole story. Further into their research, scientists discovered that both the Milky Way Galaxy and the Andromeda Galaxy are voyaging through the vastness of space towards the center of the local group of galaxies, which is located somewhere around the Virgo cluster. But it doesn't end there, because while observing the mysterious Zone of Avoidance, scientists made one more astonishing discovery, which suggests that all three massive celestial objects, that is the Milky Way Galaxy, the Andromeda Galaxy, and the local group of galaxies, are advancing at incredible pace towards the center of Laniakea supercluster. Stuck at the center of this cluster, about 147 million light-years, is the Great Attractor, with a diameter of around 300 million light-years. Astronomers found another massive supercluster of galaxies called Noma Cluster, with a total mass of about 1,000 trillion solar masses. Consequently, it turned out that there are far fewer galaxies in the Great Attractor region than previously thought. The Great Attractor itself is estimated to have more than 10 million billion times the mass of the Sun. But interestingly, this mass is only 1/10 of what scientists originally thought it would be. Within the region of space, objects located at great distances are usually dim and difficult to detect, meaning only the brightest objects are visible. Due to this phenomenon, we sometimes mistakenly associate these objects with areas of outer space where they do not belong, and this makes it seem like some regions of space are more populated by denser galaxies. So technically, it could be that what the Great Attractor is showing us might be different from the reality. In fact, it may not be a super attractor. Rather, it might just be a region of space that contains more galaxies than usual. Ironically, the Great Attractor is not massive enough to pull the local clusters of galaxies. So what exactly attracts them to the center of Laniakea supercluster? Keen to find answers to this conundrum, scientists set out to find an element with an even more powerful gravitational pull, and eventually, they found the Shapley supercluster. This supercluster is located approximately 650 million light-years away from our planet. It is a collection of around 20 clusters containing 8,000 galaxies. The Shapley is the most massive formation within a billion light-years from our Milky Way Galaxy. In addition, it weighs about 10 million billion solar masses. The Planck satellite belonging to the European Space Agency had already taken some alluring images of the core of the Shapley supercluster during its search for the oldest cosmic light. In these images, we saw the largest pink spots showing the Abe 3558 and the Able 3562 galaxies on the right and left respectively. We also got to see a couple of smaller groups that lie in between them. A computer model of a structure located opposite the Shapley cluster is helping scientists learn more intricate details about the region. With the help of this computer model, astronomers found dipole repeller, a mini region within the area with extremely low density. This supercharged gravitational force of the Shapley supercluster allows it to pull celestial bodies out of the dipole repeller. This ultimately means the dipole repeller is most likely devoid of matter. Considering that less dense regions of space are able to push around matter with the same force that over-dense regions use to attract matter, the dipole repeller is said to be associated with the flow we observe as well. With that said, the discovery of the supercluster Shapley does not exactly clarify the concept of the gravitational web, especially in regards to the great attractor. And according to Professor Matthew Collis, the director of the Research School of Astronomy and Astrophysics at the Australian National University, some aspects of the Milky Way's outstanding velocity is still yet to be explained. The professor put forward this argument after calculating the gravitational force of the Virgo cluster, the great attractor, and the Shapley supercluster, and found that it doesn't really add up. He also found that our Milky Way should be moving about 31 miles per second slower than it is currently moving. Professor Matthew Collis believes that this could be due to the forces of the several mysterious structures acting in the Milky Way Galaxy. And it's quite possible that we found one of them, which is known as the Vela supercluster. Scientific research shows that this thick cloud of dust and gas is located about 850 million light-years from our planet. This cluster is massive. It has a diameter of about 370 million light-years and contains around 100,000 galaxies, each one sparkling with hundreds of billions of stars. The Vela supercluster holds many perks for scientists. For one, it might help to explain the difference between the Milky Way's actual speed and the new speed caused by the expansion of the universe. Back in the wider scope of things, scientists have observed 883 galaxies within the zone of avoidance, many of which have never been put under the magnifying glass before. This observation was done with the help of Parkes radio telescope located in Australia. At first, astronomers identified 3 galaxy concentrations named NW1, NW2, and NW3, as well as 2 additional clusters identified by the code name CW1 and CW2, with each galaxy estimated to contain around 100 billion stars. The discovery of this phenomenon hovering right behind our own galaxy is an extraordinary achievement that had never been done before. Nobody would have believed that celestial elements with such great masses exist somewhere in the vastness of outer space. Most likely, the gravitational force of the objects is bound to affect the speed of the galaxies around them, including ours. But still, it doesn't explain the fact that the Milky Way is moving faster than it should. Hence, scientists have continued to search for other possible sources of gravity. They are also trying to solve the mysteries around the motion of the Milky Way and the local group galaxies. More often than not, discussions around invisible gravity always lead us to a phenomenon called dark matter, and it's the same in this case. For all we know, all the gravity and matter that we cannot account for may be generated by dark matter. Alternatively, it could be that these galaxies are being driven towards themselves by another mythical and hypothetical force of the universe, popularly called the dark flow. And by scientific definition, we know that dark flow is the movement of hundreds of galaxy clusters at about 2 million miles per hour in the direction of a patch of sky between the constellation Centaurus and Vela. This phenomenon was discovered by scientists at the NASA Goddard Space Flight Center while they were analyzing the data of over 1,000 clusters provided by the Wilkinson microwave. This study, which covers a large part of the observable universe, also revealed to scientists that the dark flow runs deeper into the universe than we thought. Recent estimates suggest that it could be around 2.5 billion light-years away from our solar system as it continues its journey towards the Great Attractor, as well as the constellations Centaurus and Hydra. Another scientific theory postulates that the mysterious dark flow is somehow intertwined with some other mythical world from a hypothetical multiverse, but that's a discussion for another video.